doing is a full restoration on the building, basically concerning a lot of the pointing, which we found is a failed item. So top to bottom, we're doing 100% of the pointing. Back in I believe it was the late 80s, early 90s, the building had some renovations done on it, and they used a cement mortar. And the cement mortar is actually what makes the stone fail. So if there's any movement, the joints are meant to fail and not the stone. When you've got cement in between the joints, the stone fails and not the mortar. So what we're doing here is we rake out all the pointing back to about 50 millimeters to remove all the cementitious pointing that was there before, and replace it with a heritage lime mix. It's a 2-to-1 mix. And it allows the stones to move, and if anything does move, the mortar will fail and not the stone. So we'll see down on the lower levels where the building has settled and moved. There's really no movement up here. The level above us at the moment, there's 3 metal ties that are in there that have held the building together quite well. So if you have a look here in the detailed panels, the stone's quite soft. So a lot of the details have all been washed away, or they've all been knocked off as well by previous repairs through here, little bits and pieces. So the stone itself is quite soft and very hard for us to work around. If we try to remove any of this, we'll create more damage than good. So we estimated in this area we leave it alone and just make it watertight. To our right hand side, you can see what the old roof was like, where it's got the old terracotta ridge capping, the lead flashing, and the slates themselves are a lot thinner than what we use today, so there are quite a few failed slates. What we've also installed here is a new copper guttering and ridge through the middles, so this will be very well watertight. Along with those works there on these small dormers here, the ventilations that are above the organ, we'll re-lead cap those, and you can see some of the timbers have already been replaced. Okay. In this area we've got the south transept wheel window. As you can see here, large portions of the mortar in between the wheel spokes, they've been repaired before. Now this gap here, where my hand is, that's actually meant to be touching. What's happened is the walls themselves have moved to the west and to the east. So the wheel window is now not round, it's an oval shaped. And as you can see, spokes, that's 2 o'clock, 3 o'clock and 4 o'clock have now moved to the east, which have opened them up. So what we are looking at doing is rectifying and stabilising, putting stainless steel pins, grouting them and locking them back in place to the centre hub here. So the same thing, what we've got over here, we've got the 8, 9 and 10 o'clock spoke, same issue, because they're the horizontal. The vertical ones at the top and the 3 at the bottom, because they're vertically loaded, have not moved. So what we want to do, and we're proposing, is putting a pin through the centre hub here, and it'll go at least 100 millimeters into the spoke, and that'll join it together and lock it in place. Because it's not load bearing, it will be strong enough. All we're trying to do is stop it moving further. We're not trying to bring it back together, we're trying to isolate any further movement. So we'll be using a 12 millimeter stainless steel pin, 316 grade threaded, and that should be enough, grouted in and locked in place with a non-shrink grout. That should be sufficient enough. It is a very soft sandstone they've used, so when you've got movement, it crumbles. So we'll see that further down, and you'll see some markings where we're actually replacing some stones. This is where damage is occurring, and what we can see here is where the cylinders are failing. This is what we call a cylinder detail or a moulding. And these ones had already fallen off. They weigh about 5 kilos each, so at some stage they have fallen off the building. So number one is safety. If there are people down below and that fell on you, that'd be a big problem. So what we look at, if you can see up here, we have cracks in the stone. And usually we can test to see if they're strong enough by hand. So that one there is fine, it's safe, it's sound. It's still in deteriorating condition. As you can see, a lot of the detail has fallen off here, but the stone itself is still sound. Your longevity is still there. So that stone there is being replaced because it's lost a lot of its detail, and it's also everything below it has failed as well. This is where the southeast buttress has had a lot of previous repairs. You can see an existing pin was in here. It has failed and has fallen out. Now from this point you can see the joints are opening up, and this here is your cementitious mortar. So if any movement in the stones, it's going to push everything out. You can see as we travel down, there's cracking in individual stones. Down further. So the damage itself is working its way down the buttress. And if you see this profile shot, the X's we've marked as stones to be replaced. They've failed. So I believe this one on the side has cracked vertically on that side there. It's been previously pinned and has still cracked twice. So that stone has failed. Side of the southeast buttress, again you can see pinning details that have been installed and failed. Number one, the pins are too shallow and they're not bedded down enough, but also the stones are all moving to the east and they're moving out as well. This section of the buttress has bellied, and the stones here are very soft, extremely soft, so they're cracking and failing themselves as well as the entire buttress. So this is actually where our biggest concern of movement is in the building. Both the southeast and the southwest buttresses are holding the south transept up. They're failing, which allows the walls themselves to spread to the east and the west, which then refers back to the spokes up in the wheel window. They've pulled out. So once the damage is done, what we need to do is rectify this by putting some engineering detail in it, what we call some helibar. And that's a stainless steel rod that we'll put in and bed into these courses on multiple courses, and also 16mm pins. So what we'll do is we'll lock all that back together using the correct materials, both stainless steel and also the proper heritage mix of mortar. So this is an example of where the southwest buttress is moving to the west. So you've got loose existing mortar and also a large chunk of stone that's actually fallen out over time. So it's not as bad, and usually on a building the southern facade will be the worst, where it takes a lot more wind, a lot more rain. When the sun goes into the northern hemisphere, it stays cooler and damper. So this one isn't as bad and doesn't need as much attention as the southeast buttress. This is the side of the store. This is a fully completed, depointed, repointed, cleaned wall, and it shows how nice and neat and crisp the colours are. The pointing has been struck as per the original mason's strike, so the joints are filled back up and then re-struck. And if you come into this corner, you can see the difference with the existing mortar and the mortar that we've used. This mortar here is the cement based. As you can see, it's a grey. The original bedding mortar, which was down behind the downpipe, and you can see how it's chiselled out for the downpipe, and this is our new mortar here. So this is the lower section of that buttress that has the majority of the damage, and as you can see, we've been down 2 floors of scaffold, so over 6 metres, and it's still cracking down here. And again, large amounts of the cement mortar that's been put in. It can be up to sometimes 100 millimetres inside the joint, whereas a pointing mix is commonly found up to 30 millimetres. So it's over double what's required of a stonemason's mortar. Now, what we've looked at is, as you can see, these stones here have lost all their detail. There was actually a carving that protruded about 100 millimetres out this far. So what's happened that we've worked out is water has come down here. The drip mould, which is underneath the stone, has been lost. As you can see, I can pull a lot of the stone off. The water will now track down the face, across here, and wash everything away. So that's how soft a lot of the stone is. You can crumble it up. So what we're doing is we'll replace this stone as an indent, so it's not a full replacement. So we'll put the detail back on. These will be mortar patches, so we make up a mortar repair mix, match the colour, chip it out and replace it with some pinning in there as well. This is the south transept porch. There is no movement on this. It's actually in quite good condition, as I say, except for the sides of the gable. The detailed decorative panel still intact, really good condition. As you see, we've just done all the pointing down here as well. So we've now done 100% pointing top to bottom, which in measurement is 3.2 kilometres of pointing. At 50 millimetres deep, it ends up being quite a bit of pointing. But it's one of the definite benefits of had to be done on the building. It definitely had to be done. This is the same stones, they've failed, same detail. Again, the stones will crumble in your hands. So what we propose is mortar patch here, and also a stone indent to get the carvings back in. Here's a perfect example of more exfoliating stones. And existing cement mortar that we'll be removing. It is long overdue. There has been an engineering report done, I believe back in 1989, and they sort of measured the movement of the building. Yeah. It hasn't moved a lot more since then, but once the building has moved, the stone has failed. So once you go from there, it just progressively gets worse. And it can be quite costly to restore a sandstone building. But if you keep letting it go, it will double and treble. So it's better to get it done right the first time, definitely. From this point down, it's just de-point, re-point, putting new gutters, downpipes, making sure everything's watertight. Right behind you there, that'll be re-slated, re-leaded. So everything will look really nice. Again, we've got the fishbone pattern there that you can see. And that is one of the things that can happen on a sandstone building, is because the sandstone's constantly wearing away, the gutters can get full, downpipes blocked with all sand, sediment and chips, and can cause other problems from that point on. These are the finials. So as you can see, this is the rusty ones from the dormer windows. And what we do is we wire wheel, rust treat and repaint. And you can see many of the elements are still rusted. But as a conservation point, we've done what's necessary to maintain the original fabric. So this is an area that we've already completed. The pointing has been fully removed and repointed. Now there have been a couple of indents, we'll walk up to them. And if you can see just up here, we've had a stone replacement. So that was one of the elements that had failed, and our banker masons have recreated what was there to the best of his ability with the detail we could get from the existing stones. And also, again, there's an element of all these lower elements have cracked and they're failing. But in a stonemasonry sense, it's always better to restore things that are higher up than fabric that's down low. We can always get to these at a later date. And if this fell from this point, it's not such a bad thing. While we're here, just to note that the windows that have been fully cleaned and resealed. We've had our heritage lead worker and glazier come in, and he's done a really good job on those, and they're still in very, very good condition. You can see here as well, more elements that have eroded away. This here, that would just be water damage that's come off the windows. So what we do there's no point of putting a new piece of stone in, because the stone itself across the whole face is still in good condition, but also we just rub that back to what we say sound stone and then point it back up. I'll take you up to the south porch where we've had our lead work. You can see he's got the large panels here, quite heavy, look light, very heavy. And there's quite a fair bit of work we've had to do on this. We've done stone replacements both ends. Also, the new roof's been put on. We've put the new copper guttering on this one as well, and D-point, repoint. Now, as you're going up, you might be able to see to your left, my right, there's work on the lintel. We've exposed the lintel, and you can see an existing pin there. Now, since the pin has been installed, it's cracked again to the left. And on the inside of that lintel, we've discovered that both down the left and right door reveals, they're cracked again. So that lintel has failed in about 4 spots. So at the moment, it's being held up, we assume, by the timber door frame. So if you remove the timber door frame, that could possibly fail even further. And as you're going up, you can see in the decorative panel to the left-hand side. So once one stone fails, there's always going to be more somewhere else. So you can see the decorative panel there is cracked, and that actually goes through to the inside. So that stone there is about 300 to 400 millimeters thick. Perfect example of movement is this stone here. You can actually see from this stone, the top has fallen away. That's getting close to being about 1 inch. And then again, it'll start splitting. So what we've done is we've put some new stones down below, the bottom 3 Springer stones, and also put a lead capping on the top. A lot of these stones on the top had been pitted. The stones are very soft. So instead of replacing all the stones, it was you get better value from putting a lead capping on. And as you can see, so our lead worker has had to try to make that curved wall straight again. So to the eye it looks good, but from the underside you'd see the little bit of difference. This again has just been re-slated. We've got the fishbone pattern, the 2 courses there, new guttering, and again you can see the lead work has been done down both sides of the gable. New slate, new flashings into the gully down beside the buttress stones there. As you can see, there are many different profiles of copper guttering. So we actually matched the existing guttering. We've had it hand made and rolled to match the existing. There is a lot of work involved. Luckily we've got a lot of stonemasons. This is what we do. This is quite an easy job. It's not as high as a lot of the ones we do where access is a problem. We've got really good access here. We've got room to move. I think my personal opinion, the downside to this is the quality of the stone. I think that's where the job, that's where the main item is, the quality of the stone. And when the repairs were done with a cementitious mortar with a weaker stone, as I said before, you put a strong mortar with a weak stone, stones are going to fail. And that's what's happened. So we're lucky enough to be here to make it right this time round. My expectations were, as I say, when I first turned up on this job in November last year, I wasn't expecting so much work. But once we have access and you see the movement of the building and you actually have measurements and you can touch things, and I have been fairly surprised. We knew from the start that the cementitious mortar was always going to be an issue. but we didn't think it would be 100% of the building. So that was a little bit of a surprise. The stonework failing up around the top side of that wheel window and buttresses, yes. I mean, a lot of us have been past and seen it but never picked it, so it's one of those items where the access we got, and once we were up there moving things around and depointing that area, yes, there are a lot of other problems. So, look, we were given a scope of works to come to this job site, and it could have been sufficient, but to get the job done properly, there's no point of doing half the job. That's our point of view. As per any of the works that we've recommended to do, that's part of our sort of job. If we find a problem, it's best we say this is what it is and recommend to do it. A stone failing on an upper part of a building is always a concern. If anything falls, the liability of something falling or hurting someone is a big thing. Once we turn up, we've found a lot more. And as seen in the video now, and that buttress is probably the worst part I've seen on the building. And now that we know what we're looking for, we're hoping there aren't many more surprises. The building itself is actually still in very good condition. I believe so.